This video will give some basic background on the OSIRIS-REx mission to collect samples from asteroid Bennu. So, some of the objectives return to Earth and analyze a sample of Bennu's surface. There's no drilling involved in this mission. Map the asteroid with photographs, document the sample site, where the material is going to be collected. And there is an effect on this asteroid. When sunlight is absorbed, it warms up the surface. When that light is re-emitted, thermal energy, does have an effect on the spin and the orbit of the asteroid. So that will be measured. And compare observations from close in by the spacecraft to ground-based observations. This slide I realize is small, but a little history of missions to asteroids, and there's some comments in here as well. I'll just go through these briefly. You could pause the video if you want to read more detail. Galileo spacecraft mission to Jupiter flew by and took photographs of Gaspara in 1991. So we've got that nice photography as a start. Near Shoemaker landed on asteroid in 2001, did not take off again. Deep Space One, a flyby of an asteroid and a comet. Stardust collected dust samples from a comet, did not touch the comet, but just the cloud of gas and dust around the comet, picked up particles, and somewhat successfully returned them to Earth. I'll let you read more about that. Hayabusa returned small samples from an asteroid in 2010. Rosetta was a flyby of asteroids and orbited a comet, and it had a separate lander that was successful at landing, and the main spacecraft did land on the comet as well, but these were not return missions. Dawn orbited Vesta and Minor Planet Ceres successfully for many years. Hayabusa orbited Ryugu. It touched down and took samples in 2019, and those samples should make it back to Earth in December of 2020. So a brief tour there of some of the missions to asteroids. For OSIRIS-REx, launched in September 2016, a year later it flew by the Earth to gain energy and adjust its orbit to the inclined orbit of the asteroid. And then December 2018 went into orbit around asteroid Bennu. October, hopefully collecting samples, stay in orbit around the asteroid until 2021, and then it's time to make the return cruise to Earth. And hopefully September of 2023 would be the return of the sample. So here's a view of the spacecraft. You can see a person in the background here. Gives you a little scale of the size. Large solar panels on both sides. Here's the capsule that will descend through our atmosphere on the return. There's a big heat shield, and there's parachutes behind here. 880 kilograms without the fuel for this spacecraft. 1,940 pounds when the spacecraft is on Earth would be its weight. And 2.4 meters wide is the basic instrument package behind here. Roughly 8 feet to give you a scale. So the launch, 2016, from Florida. A little bit about the asteroid. Earth's orbit, on average, is 1 astronomical unit from the Sun. Our orbit is not circular, a little bit elliptical. Bennu's orbit is more elliptical and does cross, in terms of distance, the Earth's orbit. A very small chance of any collision. The orbit is tilted, so it's not in the same plane of space around the Sun that the Earth occupies. But a few facts there about the orbit. Artist drawing. We did not have a second spacecraft to photograph the first one. That artist drawing. The collection tool is right here. This is the only part that will touch the surface, and then just briefly. But it went into orbit in 2018, started taking photographs. Very interesting surface with lots of boulders, not as smooth as was hoped before the spacecraft was launched. There are 4 sample sites that were identified, and then the Nightingale site was selected as the best choice, having good material to bring back, and also the landing is accomplished autonomously. The spacecraft computer will be matching up images with the image of the target area and controlling the descent down to the asteroid. I think it can get as low as 16 feet above the surface and decide to stop descending at that point and go back to a safe orbit. But this is about 60 feet across, this target area. And the spacecraft has to get into here and not touch any of the large boulders around the edge in the collection process. So the sample collection first attempt will be October 20th. Again, the computer is control in bringing the spacecraft down to the surface very slowly. It won't be a collision. It'll be a very soft touchdown. And then for 5 to 10 seconds, this collecting head will be near the surface. When it senses that it's at the surface, there's a small tank of nitrogen, compressed nitrogen gas that will be released and create a wind, a temporary wind on the surface in the region of this collection head, and will blow dust and soil and very small rocks into the collection head. The minimum they hope to collect is 60 grams of material. That would be a few ounces weight on the Earth, and possibly up to 1,000 grams or more of material. So that's what the hope is for the process. After the collection, the spacecraft thrusts backwards out away from the asteroid. When it's at a safe location, it will spin. It will spin itself in a controlled manner to determine how much mass was picked up. It turns out that the ability of the thrusters on the spacecraft to spin the spacecraft depends on how much mass is in that collection device. So read about moment of inertia sometime if you want the details on that, but they will determine if they've picked up enough material. And also I read in one website, but not many, that they're also going to take a photograph inside the collection bin to determine what is there. Then they'll make a decision. Possibly they'll try to touch down again at the same site or a different site to pick up more material. The goal here is to pick up quite a bit of material, much, much more material than any other mission to an asteroid has accomplished. Then we have to bring that back to Earth. So it'll stay in orbit around the asteroid until 2021, and then start its journey back to Earth. The sample will have been stowed inside this chamber here. This arm flexes, and it'll drop the collection device inside here, and then it'll be sealed back up. So a heat shield here, parachute on the back. It's designed to survive going through our atmosphere. And the target landing area is in Utah. I don't know what part of Utah, but they're going to try to guide the return such that it does land in Utah and be collected. So Tuesday, October 20th, there's coverage. You can read about these items, and hopefully Wednesday, October 21st, 4 o'clock Central, they'll have some information to share. Here are the websites. If you want more information on the asteroid, please follow these steps. Enjoy.